Yeah, it's nice. It is. I I like it. I really tried to get OBS to do what I wanted it to do, and I know that it can. I just kind of like never put enough energy into it to actually figure it out. But Streamlabs is also good. I think OBS is like a little more like beloved of the open source community, and I know there was some beef with Streamlabs, but I think they figured it out. But um, it's okay. Okay. So yeah, so we can. I guess we can give people a second to. Let's see, who's gonna. Oh, that's funny. Um, yeah, the Streamlabs, the Streamcord has made it in, so technically we are out there. I don't know if anyone's gonna show up. Um, it doesn't super matter. We will ignore that, but like we can give it like a couple of minutes.
Mhm.
Um, but yeah. So if anyone is here, which I'm going to turn off my ability to see chat. So Trent, are you on top of that?
I think so. There's this new thing. This
What?
is like new moderating chat window, which is interesting. But yeah,
Mm,
I think I can. I'm gonna try posting a message in it.
do it. Let me see if I can. Oh, Trento Delgado.
It's
Hello,
D
Trent.
Galanda. It's not Delgado.
I don't read all those words. They have
That's
enough.
fine.
Too many
It's a
letters.
lot of letters.
Yeah. Um. Yeah. Looks like you got it. So I'm just yeah. Uh. Let's see. Is there anything else to do? Feels very um non-ceremonial, uh, I don't know. There's yeah. So, anyways, I guess we've been in this chat for a few minutes, and let's go ahead and get started. So I have to. Sorry, I just realized I have a problem with my. I have two of my cameras think that they are streaming, which is not ideal. Um, on that one can just. I have six webcams on my computer right now, which is a normal number. But at least it can be like it's like red light means there's power and green light means it's streaming somewhere. And I looked up and there were two of them with green lights. I'm like, I don't know what that one's going to, so I just unplugged it.
Nice.
um, okay, yeah, false start, but let's go ahead and get started again. So, hello everybody who may or may not be here. We are here on this day to talk about FreeMoCap. So we have Kiley Hartigan, who is a member in my lab and has been working on FreeMoCap for a while and has sort of particularly been uh, taking in which kind of thing has been taking a big role in helping us set up our documentation and sort of filling out the documentation of the FreeMoCap project. And it's been a great opportunity to kind of work through like a lot of the things that are like sort of in my head and sort of wanting to get out into the world and sort of a lot of the conversations that have sort of come up around that. And So the plan for today is that Kiley has a couple of questions she wanted to ask, and so she was down to do it on a stream. So we're going to have a conversation. She's going to ask some questions. I'm going to answer them, and then that's going to be kind of mostly in service of like building up the doc, but also doing it live and doing it and sort of posting the video afterwards, so that there is a record that is available to the wider audience. And we also have old Trento de Galanarba, Trento Worth, who is also a member of my lab, who is here um, without vision. Look at him down there. And he's just hanging out and keeping an eye on the chat. And he's going to let us know if there's anything going on there that we need to be aware of. But otherwise, we're just going to have a conversation. And I cannot see the chat. I have no idea what's going on in there. And Should be fun.
Sweet. Alrighty. Um, well, let's just start off kind of high level. I think it's really valuable to understand more about why you're creating this project.
Mm-hmm.
Um, you're kind of doing so against the typical academic grain of like produced output tools. And so, why are you doing FreeMoCap the way that you're doing FreeMoCap?
Yeah, absolutely. I also just realized I muted my Zoom mic because I think that was causing some confusion for Streamlabs. So if there was echoing in the
John,
stream,
you're muted.
Yeah, John, I
I am
can't hear
muted.
you.
Oh, right. So,
There you go. Now I can hear you.
yeah, I just want to, Trent, can you turn on the audio real quick of the stream to make sure that there's no echoing happening? Because I'm streaming my audio.
It sounds
Actually,
good to me.
sounds good to you, Kylie? Can you say something?
How's it going?
Does that work? Is
Good
that good?
day.
No echoing on your side, Trent?
No echoing, you're fine.
Okay, cool. I just cool. Uh, had mic confusion.
Chat
Um,
confirmed, no echoing.
Great. Thanks, chat. Um, yeah, that's a. So yeah, that is a. That's a. So the question was, before I got distracted by technology, why am I doing this thing? What is this free mocap project, and why am I doing it in this weird non way that is sort of off of the standard model of academic science, which is a spectacular question, because I am a professor of neuroscience at Northeastern University in Boston, and I have a full scientific career behind me, and I am currently tenure track at this school, as a research professor. And anyone who knows anything about like what you do as a typical pre-tenure professor knows that what I have been doing with FreeMoCap is definitely not the traditional sort of strategy to how to get and maintain a lab and sort of get tenure at a school like the one I'm at. Um, and uh, so what you're supposed because so what you're supposed to do, the traditional route for academic success is it's almost entirely focused around publications, pump out publications in peer-reviewed journals, and you have a research program that sort of prioritizes publishing papers and getting grants too, but mostly, but the grants are also tied to publications, and that was indeed the strategy that I was working under for the majority of my academic career up until now. Um, and I, I did publish a bunch of stuff. You can check it out on Google Scholar. Look for my name, um, and that's the work that got me this job. And when I first got to Northeastern, when I was hired here, I started in the summer of 2019. That was my plan. I was just going to continue the approach that I had been under and work on publishing papers and things like that. Um, and then the pandemic happened, and a lot of things changed. From a practical perspective, the lab, I study human research, and human subjects research was sort of shut down. I lost access to my like big physical lab, and we needed some kind of a thing to work on, while we didn't have access to like the big fancy motion capture equipment in the real physical lab. So building a markerless motion capture system using webcams, or using cameras in general, and sort of like the new markerless tracking technologies that were sort of coming about, had been kind of in the back of my mind for a while, and it just seemed like a good time to start working on it. And at the time when I first started working on it in March of 2020, the plan was to just kind of do it for a little while, just to kind of like have it be a thing to sort of help us keep some level of productivity, and then but always in service of like when we get back to the lab, we'll sort of work on that real stuff. um but then what happened was I started to feel a couple things happened. One was, also to be clear, the markerless tracking thing was always in service of like the underlying research program that I'm in. It was never like a tangential thing. It was always on my same research path, because a lot of my research historically has focused on building methods to record to study the neural control of human behavior in natural environments. So I have, you look at some of my more recent publications. It's people walking outdoors on rocky terrain, wearing eye tracking, and sort of, and a big part of those studies was finding ways to record a human moving in a natural environment at a level of specificity that you could actually do research on it. So markerless tracking in unconstrained environments without suits is very much on my like traditional line research path. The main divergence that happened from my traditional line research into what FreeMoCap has become happened when I started to feel a lot of conflict about the ways that we sort of culturally think of science and education and research. And in the sort of early days of the pandemic, sort of feeling all these complicated thoughts about like the role of rights and privilege and power and responsibilities and things like that. I started to feel like the with the position that I was in and like the social power and space position that I at then very recently, and now it's been a little more time now occupied, it started to feel like kind of a bad use of resources, maybe a little bit almost selfish, to like focus all of my energy and all of my effort to enact a strategy whose main goal was frankly to like help me stay in this position of comfort and power. And a lot of the research that gets done and published, all good stuff, smart people doing their best and sort of living scientific ideals and all that, but the end results are you know PDFs, esoteric PDFs in often for-profit journals, and people and almost nobody in the world benefits from the papers that are published. It's really, the audience is always like specialists of specialists, and it started to feel like it wasn't really serving broader goals to focus so pointedly on finding ways to sort of push things into publication as quickly as possible. So, so the shift that happened was from was never to shift away from doing scientific research, but it was more to shift kind of like the framework of it into something that would be a little bit more generative and be a little bit more useful to the broader population while still maintaining its central core role of being something that I can use to do my research on the neural control of real world behavior. So the divergence that really happened was rather than doing the traditional thing of get something that's ready to go, build some research project, get it ready to go, and then push it to publication, and then kind of move on. I started to draw a lot of inspiration from large open source projects like your like Blender and things like that, and started to think about what would it look like if I was instead trying to sort of adapt my research into being kind of more of this like having this sort of open source approach where it's a open distributed large scale long term project with the goal of creating a useful artifact, like a particular tool that is useful to anyone who might want to use it, including myself as a researcher. And it's been going well. It is unbelievably more work to do this than it is to just like put together some scripts that can do the analysis that can get you the data that's publishable. Then you post the GitHub link and call it good. Actually making a tool that is stable and reliable and able to be used by anyone, not even just scientists and experts, is incredibly challenging. Has been incredibly challenging. It's taken probably like 3 or 4 publications worth of effort to get us where we are now. But I still think that it is I feel good about the choices that I made in the position that I'm in, because I think that ultimately the work that we're doing with FreeMoCap is going to have a larger impact on honestly the scientific world, as well as providing a useful tool that is sort of value to people who are outside of the ivory tower and outside of the traditions of research that I'm sort of typically a part of. You're muted.
Quick interjection. John, could you slide the chat on your stream a little bit inward so that it's not cut off visually?
Slide the chat on my stream.
Yeah, so it's like currently the chat is like cut off on the left-hand side.
Chat box. Oh, there we go. Like that.
I'll have to wait a moment and see. Yeah, that looks.
But it's black on black. You probably can't see it very well.
You can read it.
Yeah, let's see if I can get the colors. Get the colors.
White would be better.
White would be better. Background color. Where's the text color? Visual settings, font settings, Fafa. Source. I'm just gonna put the chat over Kiley's face. Sorry, Kiley. I'll put it over. I'll put it up. You've got a nice white background behind you, so I'm just gonna take advantage of that, and then we'll figure it out later.
Not too worried about it.
Yeah, you can't see it, so it's fine. I can't see it either. Is that better, Trent?
Yeah, I think that's good.
Cool.
Sweet.
Yeah.
Alrighty. So you're, it's something that I've always been really grateful for, that you're doing this in this way, because I've thought for a long time that like scientific literature is so, like, the bar is so high for like the average person to understand and interact with it, which is like a little paradoxical and counterintuitive to the age of information that we're in, and it prevents like your average person from actually being able to interact with a lot of the research. That there are there's a lot of tax funded research, and like these people can't actually understand it or interact with it. So I think what you're doing is like initiating a trend in a really important direction.
Thank you. I appreciate that, and I hope so. And I mean, I think that, like the high science, like the stuff that gets published in like the super dense, like high impact journals and all that stuff, like there's kind of a reason why it is written the way that it is. Like it kind of, at a certain level, like you kind of have to write things in that sort of super dense way. And so it's not to say that that should go away, but I think the problem that you're noticing is that there needs to be more inroads. There needs to be more like avenues to sort of like, if you hate, like, so we got like the ivory tower, and it's like, okay, maybe there should be like an on ramp to get in, like to get up to it. And that's kind of a lot of the the underlying design decisions that get made with FreeMoCap are ideally kind of in service of that kind of goal of creating something that can I talk sometimes about this, like the universal design principle, where you make something that's usable by everybody, and then everybody benefits from that. And so oftentimes what you see with scientific software is that there's already a huge barrier to entry to it. Like it's challenging, it's complicated, and a lot of the world is designed to be understandable by people that already understand it, like, and because tools are designed by experts, and so they create them in the way that an expert would want to use them. So I try to kind of, when designing FreeMoCap, I try to think about like, well, what would this look like for someone that like had no background in computer science and had no understanding in sort of history of cameras or motion capture or biomechanics or neuroscience or things like that, and trying to make something that is that would be sort of interpretable by them, but also usable by the person who is the expert in that. And it's challenging to do that. Like it's kind of things like, as you do it, it's like, oh yeah, that's why people don't do this, is because it's hard. But I still think that it's kind of, I've been thinking a lot about just like frameworks and platforms, and sort of like how important it is to sort of make a platform or a tool or a framework that people can sort of be within and work within, more than sort of trying to get really focused on like any particular avenue or application or anything like that. So FreeMoCap, people can come to it from any direction. A lot of animators, scientists, clinicians, biomechanists, people just think cameras are cool, people that just think cool softwares are cool, and every one of those people is coming from a different background for different reasons, and we really want to make a tool and an environment and a community that can welcome all types of people from all backgrounds, interests, and sort of technical skill levels. And then once they are in and they're sort of able to use the thing for whatever they want to use it for, all of a sudden there's these sort of like short pathway inroads from whatever their expertise or interests were when they came in to all the adjacent things that sort of they might want to get into. Like someone might come thinking that they're here for the animation, and then they sort of see someone posting about like biomechanics, and they're like, oh, biomechanics is cool. I mentioned many times, like, good old Mac Pribble, who's on the server, who came in with physical therapy background, and then just kind of like, he's like, hey, computer vision's super cool. And so now he's like helping us build like a new calibration tool using OpenCV and Qt and Python, like all of which were things that were not part of his background or skill set when he showed up. So we're trying.
Mhm.
These are the
Awesome.
goals.
So what you mentioned, using this tool to further your own academic
Mhm.
research. What research are you talking about?
Yeah. Let me pull up a video because I think I'm just streaming that screen, so I can do that. So so my academic background is weird and circuitous. My first degree is a bachelor's degree in philosophy, and then I was focusing on like mind and science, philosophy of mind, philosophy of science, and then tried to go to grad school for philosophy, and by grace of God, did not get accepted into any of the programs that I applied to. And so I took another year and got a job at an autism research facility and applied for jobs in sort of cognitive science and things like that. And then I got a job studying, working with Brett Fajan at Rensselaer Polytechnic Institute to study the visual control of locomotion. If you're wondering how you get into a program like that with a philosophy degree, the answer is I don't know. It's just you.
That's nice.
I well, I submitted a writing document along with the applications, even when they didn't ask for them. And at the time that they got my application, Brett was trying to help someone with a math degree write his dissertation, and he looked at my writing sample and he looked at this guy's dissertation, and he was just like, I think I'd rather teach this guy math than teach another math student how to write. Um, and
Are you at liberty to name the math student?
no.
Okay. I didn't know if it was Gabe.
It was not Gabe. Gabe came from a
Okay.
psych background, so he was
Gotcha.
so sorry, I'm looking for the this I'm just like biding my time while I'm looking for these videos. Uh, so I studied visual control of locomotion with Brett, and that was sort of the start of my like official scientific research into like the human movement. In particular, it was a focus on Brett comes from like the Gibsonian ecological background, so it was a focus on how agents interact with their environment and sort of how do you get visual information. Specifically, I was focusing on how do you get the visual information that you need to plan your footsteps out over like rocky and complex terrain. And at the time, I was doing. Sorry, I'm trying to like do things at once. I was focusing on in lab stuff, so we had projectors pointed at the ground and sort of targets and obstacles that would sort of turn on and off based off like a motion capture in the room. Oh, he had a motion capture system, an old Vicon system, that I worked with an undergraduate named Yuli Vigderchik. I wonder what he's up to. I hope he's doing well. To integrate the projector with the Vicon motion capture system to make a sort of real-time interactive sort of like projected augmented reality ground plane. After I got my PhD, I went to work with Mary Hayhoe at UT Austin, and Mary studies same kind of ideas. Let's see if that's gonna pop up. Okay. No. So Mary studies natural behavior with a focus on like eye tracking of people in natural environments. And she's one of the sort of, I think she was like the first person to ever combine eye tracking with VR. She's one of the first people to use VR for research, like back in like the 90s. And together we put together, I'm going to cover our faces real quick, this type of data. So this is me out. These are my eyeballs. I'm wearing an eye tracker. I'm out in some rocks in Shoal Creek in Austin, Texas, and this is I'm wearing a full body motion capture suit, an inertial measurement suit, sort of it's motion shadow. This is before the era of Rococos and things like that. And then the lasers coming out of the skeleton's face are the vectors of each eyeball, as measured by the eye tracker, and then this is sort of a retinal projected this is the image from the head-centered camera, and this is that sort of projected into sort of a retina-centered frame of reference. So the focus here is on a human out, so if the broad scale of this is like it's a human out in the world, full body motion capture, binocular eye tracking, and we're trying to look at the relationship between the pattern of gaze on the ground and the upcoming footholds, and then using that as a tool to try to understand the visual search process behind getting the foothold, and then also trying to like use this as a proxy to understand like what are the cognitive and neural processes that underlie locomotion and the selection of footholds in this kind of rough terrain environment. Oh, is Kiley gone? Oh, she's here. Sorry. So that's like that is my traditional line research, is that kind of stuff. And the in my work, coming into Northeastern, the plan was to take the sort of the hypotheses that were generated by that kind of like real world sort of a quasi observational kind of study, and bring it back into the lab and do sort of controlled, careful experiments. And Trent, who is postdoc in the lab, who is silently on the stream, is sort of working on that goal. So where that ties into FreeMoCap is that long story, the quick answer is now that we can record human data, I have also done some proof of concept integration of an eye tracker into FreeMoCap so that we can get laser skeletons, which is full body data plus eye tracking lasers. And so, we are now in a position to start doing more of that kind of laser skeleton natural behavior sort of neuroscience driven research, and we will in fact be sort of getting into that in the coming months. From a research perspective, like I will be enacting research that in the lab that's using that tool of sort of FreeMoCap laser skeletons. But I also want to sort of go back to like the original question you asked about like why I'm doing this in this way or whatever, and the answer is that one of the in addition to sort of like the broader world, like the problems of the inaccessibility of science to like the general public, even within the field of neuroscience, these kinds of methods, like this thing that I made, as a postdoc, that was sort of cool enough and unique enough and interesting enough that it was enough to get me a tenure track research professor job at an R1 university in Boston, which is not an easy thing to get. A lot of why this was considered unique is because other people couldn't do it. Like there's not a lot of I don't know much of any research out there that has this kind of data, like full body mocap, eye tracking, but 3D binocular eye tracking and this sort of retinal projection type of thing. And so but plenty of people have asked me like, oh, hey, we're trying to implement those things. Can we use your code? Can you set us up to do that kind of stuff too? And the answer was honestly, it's like, man, not really. Like I can't really, like I could give you the code and it's public, it's online, but like it's not going to help you. Like it's written, academic spaghetti MATLAB code. Like you got to know this, that, the other. Like there's going to be bugs. It's going to crash. It's not going to work. So again, even in the context of like the smallish scale of like academic neuroscience research, I realized that sort of the biggest impact that I can have even on this field is to make these methods something that other people can do, because I want to see more research that has full body mocap with eye tracking in the real world. And if I'm the only person out there that knows how to do those methods, then that research isn't going to get done.
Mhm.
Which, from like a strategic point of view, it's like, oh, that's an advantage. Like I'm the uniqueness. I can leverage that to sort of secure my position, which is of course again like the traditional route. But I don't think that's the best use of my energy and my time, and I would rather spend that time creating general purpose usable tools for hardcore neuroscience researchers as well as anybody else.
Mhm. Okay, got it. So,
Can we get a quick
um,
intro on like who Kiley is? Because I
Oh
don't know
yeah,
that we ever really did. Just like Kiley, you're a pretty cool person, do cool things.
I
Just
will
like a
introduce
brief
Kylie.
introduction on yourself.
I will introduce Kylie, and then Kylie can follow up as needed. Kylie
go
is
for it.
a friend slash lab member that I originally met out in the desert of Moab doing at a highlining festival, and uh, we were talking about something or another, and then I remember you brought up that I was studying human movement, and you were like, I had some thoughts about slacklining, and you laid out you had a fun sort of hypothesis theory, just thought about like gamma motor spinal neurons adaptation and sort of how that relates to slacklining, and thought it was a really cool thought, and that was in 2019, and I remember kind of thinking at the time, how like that's such a cool thought, but like, and I what how can I like make how can I like bring Kylie into like the cool part of the research world that I live in. And at the time I was like wasn't really sure. I was like, what does that mean? Like grad school? Like you want to come move to Boston to grad? That doesn't seem like Kylie's vibe. And then when the pandemic happened, um, it was like, okay, well, the entire lab is through a webcam. So Kylie, you want to just like pop on a webcam and sort of join lab meeting? And that was 3 years ago. And now you've been
Mhm.
in the lab and doing cool stuff and sort of like picking up a lot of cool techie skills. Uh,
Mhm.
in her spare time, Kylie also does skydiving instructor and highlining, not instructor, skydiving student. Yeah.
I just skydive for fun.
Oh,
Just
okay.
me, myself,
So
and I.
you talk about it to the point I was like, oh, you must be teaching it.
Nope, not yet. No.
But yeah, so that's my
No.
introduction of Kylie.
Yeah. So I was just really super stoked on this project because I thought that it'd be a perfect combination of my passions and contributing to the like to actually studying these things is like how do humans walk on high lines? Like why is that possible? And what's the like the learning curve from a neuroscience perspective? Like how do our bodies learn to do it? Because nobody can just walk on a slack line like that. So it's
Mm-hmm.
like there's um, a learning curve, and I was studying molecular biology and physiology at the time. Oh no, I'd graduated. Yeah, I just graduated when I met you. And so yeah, so it's been really interesting to get involved in this project, and now in this like documentation capacity
Mm-hmm.
as um, to in a way that dovetails with what you're trying to make happen, which is like let's make sure that people actually can use this tool
Yeah.
because it's really valuable that it can happen.
Yeah, totally. And I think that the model of like, you make the tool and it's kind of like, what are the applications of this? It's like, well, you can do whatever you want with it, And so I think
Yeah.
it's like once something like this exists, and it's like, oh wait, we can maybe study slacklining or highlining even, and like
Exactly.
actually, and once you can get the data, once you can record something, you can study it. Like or put another
Yeah.
way, you can't study something that you can't measure. And
Right.
so that's the general aspect of this. It's like whatever my applications for FreeMoCap or any research tool might be, um, the impact will only be so much as like the questions that I ask. Whereas if you make a general purpose tool, then all of a sudden people from other backgrounds, like I also want to study highlining and slacklining, but if I didn't, you could still see what I'm doing and see what we're doing and be like, that's what I want to use that tool for. And then if we've made the tool well, you can then do that. And I think that's the hope.
Yeah. Someplace somewhere is a pile of data of skydivers with
It's
FreeMoCap. It's
yeah.
really exciting.
we have a lot of we have we have the skydivers landing, we have some highliners, we have people on a steer wheel, we have people on a like pro trampoline people, and they're all sitting sort of in the weeds, like with a little tag on it that says like process these when you're ready to process these, and we're so close to being ready because it's like we record that data, we try to push it through the software at the time, and it's like, oh, it's not quite there yet, which again, like that's one of those times where like the traditional approach is like start making a bunch of weird moves and like hack through it and like get the data and then get the data and then publish it. And then the strategic thing that we didn't do is we didn't do that, and instead we sort of like, oh, like let's let these recordings and these new data sets show us the holes in our pipeline, and then let's work on fixing those holes, which means that you wind up like sitting on piles of data for literal years. But we're like, once we are ready to basically, once we handle like, you know, GoPro synchronization, YOLO cropping, and then that handling that whatever that media pipe error, like once those dominoes fall, all of those data sets are sort of like ready for prime time. So
yeah,
we'll get there.
Yeah. So speaking of the pipeline, could you spend a little bit of time talking about how this software actually works and like from beginning to end, like what is the sequence of how does one FreeMoCap?
That's another good question. I'm trying to think of the right way to, what's the most effective way for me to like describe this. And I think, can I draw on this screen? There's like a keyboard shortcut that I forgot.
You could pull up the GUI and talk through what's happening at every stage.
Oh, that's true. Can I do that? Yes.
Yeah, that's a good idea.
Yeah, let me do that. I think this is the one I want. So I will pop up the GUI. It's is it running? How are we doing? I've been working on the Skelly Cam package, which is imminent, which we can talk about in a bit. But yeah, there we go. Good job, buddy. Okay. But in the meantime, we can talk about this. I want to, let's see. I guess I'm gonna hide our faces again. It's sort of, no wait, can I do that? Actually, let's do this. No. Oh, there we go. I'll put you here, and I'll put you. If this was a better software, the better GUI would handle this resizing. Oh, I should actually handle that just fine. Okay. So, this is what we've been calling the alpha GUI. It is, you can currently run it. It's on the repo. The instructions are right there. It does its job reasonably well, but it's not where I want it to be. So it's kind of, it's got the inner, so I did not write Python until the pandemic started. I wrote code in MATLAB, and I've been learning Python, and I keep hitting these kind of like what are they called, like tiers of sort of like coding skill and coding capacity. And about a year ago, I'd maxed out like what I was able to do, and I was like, as I was like working Aaron Cherian through the pre-alpha code, like coaching him to like write that code base, which he did and did a great job. um, it hit this point where the pipeline did its job reasonably well, but like it just wasn't quite set up to grow. Like it was just, the code was too spaghetti-ish and sort of not testable, and it just kind of felt like to go beyond what it was in the pre-alpha stage was just going to take a skill level beyond my own. So I reached out to my friend Endurance Adehan, who is now the chief technology officer of FreeMoCap. And he is a very experienced software developer. I think he's got 13 plus years of experience doing software development. And I was like, hey, Endurance, I'm working on this project and I need some help. Can you help me out? And he saw it and he's like, that's a fun project. Sure, I'll help you out. And so he basically started mentoring me about like how to do like proper modern like sort of like industry standard best practices software development. And we worked together sort of in like a mentor mentee kind of way for a while. And he like gave me, he like looked at my code and was like, do this instead. And I did this. And he looked at that and he's like, do this instead. So we kind of would iterate on like, we would talk about like software development and architecture and sort of best practices and whatnot. Then I would go and try to write a bunch of code and I'd show it to him and he'd be, give me pointers. And so this alpha GUI sort of came out of the basically the skill level I was at probably like the beginning of the summer. And I put it together and it does a pretty good job, but it still, this was the first like fully fledged like GUI interface that I had really made. So the underlying code has a lot of that flavor of like I was learning how to do it while I was doing it. And so when that's what you're doing, typically you go back and you see the stuff that you did when you started, which is the most important part. And you're like, yes, I would not have done it in that way, and that's why architecture is important. So this alpha GUI is good, but I just wanted to point out that like a lot of the inner workings of it, and honestly the front end of it is going to change. The focus of this was to make something that was functional and did all of the things that need to be done, so that and then from that place we could build something that's cleaned up, refactored, and streamlined and stuff like that.
Hey John.
Yeah.
Could you share your screen so that I can kind of? Would that work?
You can't see, right? Sorry, I was. Yes. I'm streaming too many things. And I can do that. Like that. Okay. How's that?
Great.
Cool.
Now I see what you mean by the chat issue.
There's a lot going on, yeah. Oh yeah, and looks like people are talking there. So here's the GUI, and let me also just walk through like what a.
Maybe hide the chat while you have the GUI up there.
Am I not hiding chat?
No.
Oh, I see. Because I see what you're saying, like the overlay of the chat.
Yeah, the overlay just like it make like if people are gonna. Yeah. Okay. Actually, it just like loaded for me. It's not. It'd be better. This is better. Yeah, just hide it.
Better and cleaner. Yeah.
Yeah, I agree.
I think like when this goes to YouTube, there won't be a record of the chat. But if anyone, apologies for the people who are writing. I'm sure what you're doing there is great. The world may not see it. It will be saved. It will be saved on. I think you can rewatch it on Twitch and you can see the chat. But yeah. Anyways, so let us walk through can this run? We're gonna try to do a recording with this. I am not sure if it will work and like all the way through, because one of the bottlenecks in this version of the GUI is the way that it interacts with the cameras is like not efficient and for a lot of complicated ways. But I think if I just set up if I set it to record from just 2 cameras or 3 cameras, it should be able to handle it, but it might not. We'll see. If it doesn't, we'll just pantomime. Because I'm streaming on Streamlabs and on Zoom, so it's a lot. It's asking a lot. It's a powerful computer, but it's asking a lot. So let's see. So here we are. Welcome to FreeMoCap, early version of software, blah, blah, blah. There's a little ping that you can turn off if you don't want us to. If you check that, if the box is checked, it will send like a ping to a secure service that will just let us know when people are using it and what stage of the pipeline you got to. Like, did you make a video, things like that. You can turn that off if you're not comfortable with it, but it is incredibly valuable for us to have that information, both because it helps us to make the software better, and also because we can use it as evidence of usage, which is absolutely critical to getting like funding and support for this project. In the pre-alpha, there was this sort of thing where it's like people talked about it. It seemed like they were using it, but we had no information about who was actually out there using the software. So that this, yeah, please keep the box checked. We appreciate it. And if you're curious about what is actually being sent, if you just go into the code and search for pipe dream pings, I think pipe dream, or just ping, I think will work. You can just see everything that is getting saved, and you can see that, and we'll make that more obvious at some point. Anyway, so I'm going to go ahead and create a new session, and when that happens, it generates a session ID. Oh, I should have this running in the background. There's not, one of the other sort of bottlenecks is that there's not a lot of feedback in the GUI about what's happening. A lot of stuff, logs get pushed into the terminal, but there's no way to see that from the GUI yet. So we have to kind of keep the terminal up in the background if you want to know what's happening. So when I click Start Session, it generates a session ID, which is session underscore year, month, day, underscore hour, minute, second. There's these checkbox things. This session ID is going to be the title of the folder that's going to have all the data for the session in it. And so when I click on that, it generates that folder and puts it in the FreeMoCap data folder, and then shows what's going on there. And then it tries to, because I had those buttons to automatically detect, it tries to detect all the cameras, and it found 4 of my 6 cameras. Wait, I unplugged one, I'm streaming from one, and there are 4 remaining, and here they are. But I am going to, again, quick aside about the cameras. So like I've said, this is the bottleneck right now in this current recording. And so the strategy that we've been taking is working with Endurance, we've split the repository, and basically what we're going to be doing over the next couple of months is taking a lot of like the core aspects of this FreeMoCap core software and pulling the different aspects of them into their own individual repositories and packages. And first on that list is SkellyCam, which is a new package that is it's still in the works, but it's pretty much functional. And it basically handles all the camera stuff, and it does it in a much more sophisticated and modular and scalable way than this current version. And so the idea is that now that SkellyCam is its own package, I'm going to go back into FreeMoCap, and then when I need to do any camera stuff, I just import SkellyCam and then handle all the camera stuff from that. So that allows us to be more separated and sort of modular about the approach. And then also has this, now there's a new package called SkellyCam, and it handles detecting in multiple cameras, synchronizing video streams, and does all of that kind of independently of the broader FreeMoCap project. So yeah, so if anything goes wrong here, don't get too upset, because we're working on it. So that's camera 3, that's camera 0. So I'm gonna keep.
That looks good.
It looks, you can see how it's jelly. And you probably can't see it, but I can feel that there's some, it's okay. And it's okay on my computer, and my computer is like a monster.
I think I get a fair point.
Yeah. Also, it starts getting frame droppy when you start actually recording from it. So I'm just going to do 2 cameras for now. It's very dark, so I'm going to turn the exposure up. Oh wait, that was 3 I wanted, not 4. Apply settings and launch cameras. Does that work? I think it should work. Also, you like how the it starts too small and then it slowly grows. It's because I'm not doing the resizing really properly, so that's fine.
It feels like it's like coming out of a cocoon. I like it.
I don't hate it. It's like it's a bug,
Yeah,
but I
it's
don't
not that
hate
bad.
it. It's a little bit like
Yeah. What do people think about the growing window? I'm asking the chat.
You know, so
anyway, we'll find out.
Yeah, the black bars around it too are also because I was trying to like understand like the widget sizing and all that stuff.
John, it's pretty kick-ass, but like you basically taught yourself Python 4 years ago, and like it's really, really, this is really cool.
It goes. You just if you keep working on something, you get better at it. Especially if you have people you can ask for help. That was really the because it's like there's all these huge, and that's actually again back into the sort of the central vibe of FreeMoCap is like a lot of things have relatively shallow learning curves after this like brick wall at the beginning. And as someone who went from a philosophy major to like a computational sort of engineering neuroscience kind of perspective, I remember all of those brick walls. I hit them when I was like 30. And I remember how frustrating it was to sort of like read instructions that were just written for somebody else. It's like, and they things like, like, oh yeah, then just go add like, I would find these instruction manuals and be like, oh yeah, and then go then add it to your path and you're good. And I was like, I don't know what the path is. I don't know where to find it. I don't know what that is, or like, and I don't know how to Google what is a path. And so there's all these things that are like that sort of like they become simple, and you later understand it's like this is why they said it in that way. But there's just these barriers to entry, and so a lot of the goal of FreeMoCap is to sort of have these little inroads. So it's like, so this thing down here it's a fully functional Python console. Like you can f equals 9f, f times f, f8f times f, like that's so that was something that really killed me when I was first trying to get started is like, how do you actually do Python? Like, how do you run anything? It's like, oh, you got to do a virtual environment and like install your packages. And it's like, I don't know what any of that means. So a lot of this, so thank you. It was hard. But I don't think it needed to be that hard. And it's kind of making that kind of path easier is a big goal of this project, just by making like, hey, here's a thing for experts to learn things that they may not be an expert in. Because I think that happens a lot. It's like you develop an expertise in a particular area, and then if you're like if you're like an experienced neuroscientist or a physical therapist or whatever, and you want to learn Python, it is so painful to try to like go back to like true zero and like beginner stuff and like doing like oh, here's baby's first Python, like sort this grocery list. It's like, I don't want to sort that grocery list. I want to calculate, knee torque. And like, there's all this. And so it's a problem, I think, when like the physical therapist should learn Python, but there's not tools out there for experts to learn the basics of other fields. So with this project, considering like how many millions of things it touches, that's part of the goal. Is like you come here for the knee torques, then you stay for the Pythons, or vice versa. That's the thought.
Yeah, well said.
Yeah. Okay, so yeah, see, look at that. You see that little jelly move on my fingers. I don't know if that's coming out through the stream, but that's like a rolling shutter thing, and it's a frame rate problem. So we'll see how this actually looks in the record. I don't know if you can see it, but like my hand kind of looks like
it's a little bit.
Yeah. It's something like one of the nice things about cameras is that it's like it's me, like that's me, hello. And so I can sort of use my knowledge of myself as like a calibration kind of thing. Like I have a very strong sense of my own movement, like when I move my hand. And so if I look at the image of my hand and I sort of like, is that happening at the same time? Is that what my hand is actually doing? I have learned over time how to like use that to like diagnose problems. And so and so things like I can like Trent's like, oh, it looks good. I'm like, no, 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 it's got problems. Like that's something that I like learned how to do. And because it is a camera and is just displaying videos and images, and because I am a haplorine primate that is highly visually specialized, the data is presented in exactly the way that evolution has like shaped me to have the strongest intuitions. And so even as I might be struggling with some of like the computational, the technological space of things, it's still being projected into this kind of like very intuitive visual space that you can just ask, are the cameras working? It's like, well, I don't know what's the process, what's the resources, yada yada. It's like, no, 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 just like look at the video. Does it look good? If it looks good, it's probably working. And that's that kind of like autological validation where you just like you set things up in such a way that you can just look at them, and your intuition about whether or not it's good, it's not the be all end all, but it's a good way to be. And that's something that you get with cameras and spatial data, and you don't get it with the more abstract things. Like if we were like doing like hardcore electrical engineering, or like like cell biology or something that or like big data statistics, like those things may not have like as such an obvious like intuitive visual component. And because of that, it would be harder to like teach yourself things like that. Like because a lot of this is self-taught, I really wound up relying on those kind of like intuition hacks where you can kind of like put it into a space that you can just basically just iterate. And it's like, you know, push the button, did it work? No. Push the button, did it work? No. And then just like try every possible combination of things until the thing that pops out is the thing that you expect to pop out. Um, so yeah, okay. So yes, we are in. So here we are on the GUI, and we're doing step one, which is setting up the cameras. Um, and the cameras are doing okay. It's dark in this room. I'm gonna uncover this window so that's a little more light. And I'll point lights at me.
I know right now you're kind of answering the question of how does the software work. But since you're talking about lighting, that's also another mention
Yeah.
or thing that we wanted to discuss. So do you want to give just a bit of a dive into how you should set up your lighting and camera settings and all that kind of good stuff?
Yeah, absolutely. So you're working with cameras, so light's really important. And like that's so a camera is a tool that has a little sensor on it. I have some busted one on here somewhere. I don't know if I can find it, but somewhere in my like pile of techno garbage on my desk. But so what a camera does is it has it's a little chip, and on the chip there's a little silicone wafer um, that that is set up that it basically it pulls measurements of the intensity of photons that are hitting that sensor, whatever, however many times per second. And so that's the base level measurement, is the pattern of voltages on the camera sensor however many times per second for your camera. And so as in terms of a FreeMoCap as a measurement tool, that's the measurement, is light coming into a camera. Everything else that we might want to derive from that in terms of like movement and skeletons and calibration, yada yada, all of that is derived from the voltages on the camera sensor. So what that is to say is that setting up your lighting is really important because that's the data you're actually recording. The main thing to think about, and there's actually with the three images on the screen, there's a nice sort of representation here. The main thing to think about with the cameras, with the lighting, is you want to make your scene, your environment as bright as it can be, and then turn the exposure settings as low as you can get them, like as low as you can get like good looking images. Typically that is going to be, so the exposure here is measured in this like kind of unintuitive way where it's like negative numbers, and that corresponds to, let me get the OpenCV exposure. This post from someone from a million years ago. So the exposure setting here, between 0 and -13, and this corresponds to the exposure time. So how long is it's not a real physical shutter on the camera, but for every frame, how long in seconds is the sensor actually measuring light? So we tend to hang out around around -7. It's detecting light for 7.8 milliseconds. At -9, it's detecting light for 2 milliseconds. That's important. We'll get to that in a second. So typically, the zoom camera on the right here, that's using it's set to like auto exposure, and as you can tell, it's super bright, it's super washed out. Part of it's because these are really shitty cameras. That's part of a part of FreeMoCap is we're trying to make it work on like the cheapest possible cameras, just to keep accessibility high, and on the assumption that research cameras solve a lot of good hardware makes your life easier. So bad hardware makes you write better code. But typically the auto exposure settings will have your images be brighter than we really want them to be for FreeMoCap. So what we want to do is we want to turn those exposure settings down as low as you can get them, so that the exposure time is as short as you can get it. And the reason for that is if you look at the images on the GUI, when I move my hand, it's not as crisp as it could be because this room is kind of dark. But look at my finger in the FreeMoCap GUI cameras versus in the zoom window. Like in the FreeMoCap channel, it's pretty crisp. Like it's a little blurry, but it's not that bad. In the zoom window, my hand is totally blurred when I'm moving it because the exposure is higher. So if the exposure is whatever, where's that thing? Did I close it? So if the exposure is, if it's negative whatever 4, which I don't know if it's that low, but that means that the shutter is detecting light for 62.5 milliseconds. So whatever distance my hand travels in 62.5 milliseconds is going to show up as a blur on that image. Whereas if it's set to -9, it's only open for 2 milliseconds. So my hand is not moving very far in 2 milliseconds. So the image the camera will capture can be crisp. Why that's important is that later when we actually try to we're trying to feed these videos into like the skeleton detectors, they're mostly seeing still images. There's a little bit of knowledge of like the previous image helps to predict the next image kind of thing. But mostly when you're doing the actual skeleton detection, it doesn't know that it's a video. It's just seeing still images at a time. So if the images that you're feeding it, you're saying, oh, detect my hand in this image. And then if on the image on the right, the zoom channel, if the image of my hand is blurry, it's not going to be able to detect the location of my hand because it's unspecified on that frame. It's a blur. Whereas on the right, if I move my hand and it's more crisp, then when you ask the neural network, hey, draw, detect my wrist, detect my fingers, it has a better chance of doing that because you're giving it like a nice, crisp, clean image to work from. The intuition I often will refer back to is like, when you're trying to like track, you're thinking about like these like machine learning driven trackers and methods and things like that. If you as the human could go through with a marker and like mark all the things that you are trying to track automatically, then the machine learning algorithm neural network has the possibility of doing it. If you with your human eyes look at the image and you're like, I actually don't know where your wrist is on this frame, then the machine learning algorithm is not going to have a good time with that either. So a lot of it is so in terms of lighting, it's about making nice looking images that have low blur, and often that will result in having images being darker than you would normally expect for them to be in most settings. So it kind of picks up this like nice like art noir vibe. Like I feel like I'm like a sort of like a it's all very dark and gritty. But this tends to be more like the settings on the right look pretty. It's still a bit dark. I wish there was more light, but this is good enough for our purposes here. That makes sense?
Yeah, it makes sense. And is there a benefit to like actually wearing clothing that is like what be of better contrast against your environment as well, given like that you're kind of intentionally darkening the screen. If you were wearing like a white jacket right now, that would actually be quite helpful for the machine
Yeah,
learning.
yeah. So that's a good point. Like you can set up the environment in a ways to make the job easier. I typically don't do that. Mostly, uh, so one thing that if I were trying to get like the highest best quality recordings, I would put like a white sheet backdrop, maybe a black sheet backdrop, um, and then I'd wear, like you can see in some of my videos, I'll wear like a tank top and like shorts, so that specifically so like my joints are visible. I don't want to be wearing like baggy clothing, and I also don't want to be wearing like all black. So we're gonna talk. I think you wanted to ask. We're probably gonna run out of time, but like when Aaron has been recording like some validation studies, he's doing joint recordings of like FreeMoCap plus like traditional Qualisys marker-based motion capture. And so for that, he was wearing like the black suit of the motion capture system, and that makes it harder to track with FreeMoCap because he's wearing black on black, and he's like standing with black shoes on a black mat, and like that's gonna be harder because like the information, like capital I information, like Shannon information, the information available in the image has a lower signal to noise ratio because again, just
Mm-hmm.
even from this intuitive sense, like is it easier to see my hand when it's behind the black on like the dark purple of my sweater, or is it easier to see it if it's got like you know whatever. It's not a good example, but like if it was like a white on white, like a much brighter background, like it's just harder to detect if you have like white with a bright background versus if it's white with a dark background. Also worth noting,
Mm-hmm.
I am saying this as someone with very light skin. If you are someone with darker skin, you want to think about it in terms of contrast, and also like lighting and settings and things like that. You want to think about it in terms again of your intuitive sense of like, do I look good in this image? Is it a good image that can be detected? If your skin is darker than mine, your settings are going to be different than mine. So there's not. I don't want to. I tend to look for like these -7s, -8s, -9s for with such and such a lighting, but it's not a hard numbers thing. It's really an intuitive thing. Like look at the image, is it a good image? Can you see yourself? And sort of, and a lot of it's kind of like building intuitions based off of that. Yeah.
Got
Okay.
it. Sweet. Yeah, that's it. I guess we'll dive into more detail there later of like how do I get the best quality, most reliable recordings. But for now, let's stay on the main thread of
Yeah.
how does
Let's
the
let's
software
push let's push this
work.
through. So yeah. So setting number one over here is we set up our cameras. That's the main thing. Point your cameras in the right direction. I have these two images. They're on both sides of my monitor. Um, they're not really ideal, but they're good enough. And with only two cameras, it's going to be hard. But there's overlapping fields of view from both, and the settings are good. The lightings are fine, good enough. So now I have to calibrate the cameras, and what that means is so to do. Oh, that's cool. It is detecting. Um, so we're using a multi-camera system for FreeMoCap, like a traditional motion capture system. You have a bunch of cameras, and each of those cameras gets a two-dimensional image, and then you can triangulate from the multiple views to reconstruct a 3D skeleton. Um, and in order to do that, you have to know the location of each cameras relative to each other. The idea is that if you are detecting, so it's auto. This is called the Charuko board. It's being auto detected by the camera, um, and it's basically looking for the corners between these two Aruko fiducial markers, and basically this process will sort of help. The cameras are taking measurements of the location of the board in their field of view, and we are synchronizing the videos behind the scenes. Um, and so basically, there's the software assumes that you're tracking the same board in multiple cameras, and so it can use the shared viewpoints to know it's like, okay, if camera one if we're seeing the board over here on this side of the screen, and camera 3, we're seeing the camera over there on that side of the screen, and we know the layout of the board, and we know the shape of the board, we know the size of the board, then we can use, so we know the shape of the board, we know the size of the board, we know that there is a camera 1, there's a camera 2, but we don't know the location of those cameras. So we can basically take the knowledge we have of this calibration grid, and then doing some complicated math behind the scenes, you can calculate the location of the cameras relative by using this sort of shared view of a known object. And so I'm going to just start the recording real quick. So I'm going to begin recording. It's still doing that printing save frame in a loop to the terminal, which is hilarious. And now what I'm doing is I'm just basically holding the board so that each camera gets a nice sort of group of images from it. And I'm going to say stop recording, and then it does some synchronization in the background. We're still doing post-hoc synchronization using timestamps, but it's fine. And yep, and then it saves. These are the 2 videos that we recorded, and this is a diagnostic plot of the timestamps, which actually looks pretty okay. We just do cameras, like you could, like this, like weird heavy tail, that's the GUI acting up. But basically, I don't want to go too into details here, but like camera 0, camera 1, camera 0 is blue, camera 1 is orange, and from whatever, there's 500-ish frames, and this is the frame number versus the timestamp, and they nicely line up, and then they're roughly peaking around 33 frames per second, which is 33 milliseconds per frame, which is roughly 30 frames per second, which is what they should be. So we got so the camera is recording reasonably well here. Now what I'm going to do is, this is a lesson I had to learn as well. With this GUI where it is right now, if you want things to happen efficiently, actually it's already running it in the background. I'm going to turn off the cameras here, because the challenge of the code, like the GUI right now, the biggest bottleneck is like everything is competing for the same resources. So the camera process is competing with the calibration computational process, because we haven't split those up into like multi-processing and things like that. It's threading, so it is threaded, but it is Python, so it's all in the same process. So what that means is that if we're looking at the cameras here, that's taking computational juices away from this calibration process. So to get that to run faster, I am going to actually, I'm going to wait. Am I going to wait? No, I'm going to turn. You can see there's a part later where it shows like items per second, and if you let it run and you turn off the cameras, you can see it jump up like by like a factor of like 10. So I'm going to turn these cameras off, and you can see it speed up. So pro tip: turn off your cameras when you're not recording videos. Okay, any post calibration was successful.
Nice.
And that produced this calibration.toml file, which has camera 0, camera 1. The names don't match up, and that bothers me, but don't worry about that. We'll fix it. And then this has basically the information for the cameras. So the camera matrix is a 3x3 matrix, and then the important parts are the translation. So camera 0 is defined to be at 0, 0, 0. And then and the rotation is Euler angles, X, Y, and Z. So each camera has 3 positional data, X, Y, and Z, and then 3 rotational data, and that defines the 6th degree of freedom position in space, information about distortion, matrices, yada, yada. And so we now have the information about the camera locations from that process, and we can use that going forward in the next part. Okay, so now that we have those calibrations, we can go into this, and I gotta turn the cameras back on. Apply settings and launch cameras. Do that. Hey, I'm always like a little shocked when it works. It works reliably, but like it still seems like magic to me.
Hey John, I just want to name the time. We've got about 10 minutes before I've got to sign off.
Yeah, we can wrap up, and then we can. I'll be happy to wrap up then too.
Yeah.
So I'm going to do a quick recording. It's going to be janky because I'm sitting down. I'm sitting down with two cameras, but it'll just be real quick. So I'm just going to start recording, and I'm going to do some fun things that will hopefully look good. And I'm going to keep it short so that the recording will take too long. Does the synchronization. It saves videos to the synchronized videos folder. Same as before. It's got, here's all the timestamps. Here's the diagnostic plots. Oh, and here it is. So now it is running the videos through MediaPipe. And if you look down here, it says 4 frames per second. That means it's processing 4 frames per second. It's doing them one after another, which is obviously also not very fast. We could parallelize that, but watch this. When I turn off the cameras, it'll jump from 4 frames per second to 12. So a factor of 3 increase. So that's good. It's 229 frames in each video, which means it should happen process pretty quickly. And it's just 2 frames, so 2 cameras. So what this is doing is it's going through with the synchronized videos and detecting and using MediaPipe to detect my body in the image. So this is in the annotated videos folder. And it's detecting my face. It's doing an okay job of my hands and my arms, and it can't detect the rest of my body because it can't see it. So this is now camera 0 or whatever, and that is going to be the 2-dimensional data from that camera that's going to be combined with the camera calibration information in order to create the output, which hopefully will work. Oh, it's pumping it to Blender. Yeah, there we go. So this is the visualization. It does an okay job. There's some weirdness in there, like we don't handle like dropped frames super well, or like tracker loss very well, so the hands get like stuck in place. There's like a lot of cleanup that needs to be done. And then this is the same data in Blender. It's got these like weird floating bones because it does. Don't worry about it. So sometimes if it pops up with like big bones, just delete them. And I'm currently I'm working with CG Tinker to build a new Blender output that is better. So that'll hopefully come out sometime in the next couple weeks. Rotate around X, grab in Z, grab U, grab in X, and then I press Z and I turn on material preview, and I'm also going to turn off and yeah, there we go. Let me see if I can turn off that. And yeah, so that's pretty much the output there. It looks reasonably okay for 2 cameras. It's obviously it's got some issues with the fingers, and it's got issues. It's just got issues. It's fine. The Blender output is going to be is a big part of the development plan for the next couple months, and just like having a more robust and usable output into Blender armatures, so that animators can then use it. And the idea is we're particularly focusing on Blender as the first output, and then once we have that working, then ports to things like Unreal or Unity or Godot can just kind of be built on the same architecture. But and then where's did the other one?
The one thing I noticed there is that even though the MediaPipe skeleton, like the limb occlusion, caused the MediaPipe skeleton to disappear for a moment, Blender still exists in those frames.
Yeah, so that's a good point. So in this Blender data, these little empties here, those are the actual raw data that FreeMoCap produces. Those are equivalent to sort of 3D trajectories. I think the GUI actually crashed, so I'm going to restart it and to show you how to do that. But yeah, there we go. So if it crashes when we start, I can just hit Control D, and it will reload the previous session. So this is the session that we were just working under. And if we look, can I do this? Yeah. So these little dots here, that's the raw data. And those are basically like XYZ trajectories. Like the white lines are just connecting the dots, and those little blue dots are the things that's the triangulated 3D points from the two images. If you go over here to Blender now, those little 3D points correspond to these empties, these like little circles that are called empties, meaning like they exist in the 3D space, but they have no other data other than their location. And so that's what's actually being, that's what FreeMoCap is actually sending to Blender. And then the rest of this big gray thing, that's an armature. That is a like a sort of a kind of like a model rig of like a humanoid skeleton that we are using various methods to drive the skeleton based off of the empty marker data, off the empty the joint trajectory data. So that's why, and so the thing, so when the if there's like a gap in the data, which like some sort of hiccup, the armature can exist beyond that. And one of the things we're going to be doing for making it more sophisticated is being smarter about how we handle things like gap filling, and how do we handle missing data, and how do we draw more armature based off of incomplete and noisy data, which is again, that's part of the scientific process. And all measurements are noisy, all measurements are inaccurate. So the question is like, how do you work with the data that you can get? And the answer is you ask experts and they help you. Because yeah, like there's a lot of things about, like, I made the code to like do this Blender output, and I am not an animator. And so when animators look at it, they're like, oh, this is janky and hard to work with. It's like, that doesn't surprise me. So I'll be working with CG Tinker and his cool add-on, Blender MoCap, which actually I think I can just show that here. Delete, and then I can say this is like part of my fork of CG Tinker's thing. But I don't know if it'll work. Oh yeah, there we go. No, load. I don't know if this is gonna work, but basically, CG Tinker is an animator and has made this add-on for streaming media pipe data, and we were going to work together on basically using this as a method to load and process and create Blender animations from FreeMoCap data. And he is using like drivers to drive like this sort of standard Rigify rig. And so the end result, I think, will be far more robust and sort of more directly usable by people who come from this backgrounds, because anything that you can do with like Blender's like default Rigify MetaHuman will be the data that you get out of FreeMoCap, which is great.
That's awesome.
Yeah.
All right. Does that kind of
I think that about
complete
that's about our time.
The question of does that complete the question of like, how does the software work? I think it does a pretty good job.
That's the start to finish. I mean, the answer is it works okay. The answer is it's worse today than it will ever be in the future, and that will remain true over time. You can get data out of it, and it's like, but really, and there are tools and tricks and methods to get better, but a lot of it, honestly, is just intuition. It's just like time on task, like just pump them out. Like a lot of the focus behind this project was just like really making the process like iterable, and like the best way to get good at something is to do it a lot. So the best way to get good at getting FreeMoCap recordings is to do them a lot. I'm going to show you there. Oh wait, how do I don't want to show you too much of my life. But like, these are the sessions that I've recorded since moving to this part of the folder. This one, and no, not that one.
You stopped sharing your screen on Zoom.
Oh yeah, I did, but it's fine. Hundreds. I have hundreds of these recordings on my computer, and they're not all like full recordings. Some of them there's just like click it, start it, blah blah blah. But like, it's a skill. Like, and I think that's something we learned going with this project, was like, no matter how easy and smooth and clean and streamlined the process we get the software, getting good motion capture data and like setting up your cameras and like having intuition about the lighting and the pointing and this kind of that and that yada, is always going to be a kind of a technical skill. And the goal is to make that as barrier of entry as low as possible. But even after we do that, it's always going to be something that you can be better at if you try it more, like any skill. And so that's where we are.
Yeah. Alrighty. Well, we got through part of what we wanted to get through today, so we'll probably have a follow-up Q&A recording or live stream like we're doing now, but I'll probably come after the holidays or something.
Awesome. Yeah, I mean, this was super fun, and like I was saying before, like
yeah, I enjoyed it.
It's so much easier for me to talk about stuff when people ask me the question. Like if I'm just sitting here on my own trying to like, oh, what do I need to share? Like it's just hard. So I think, you know, you have such a good perspective on like you're interested and stoked and like into the project, but like you don't have a lot of the background. So I think the questions that you come with tend to be very like, yes, that is a great question to be asking. That is something that should be clarified. So yeah, more of these in the future.
Sweet. Yeah. All right. Well, I'll catch you.
Have a good one. I'll stick around and talk to chat for a bit, and then I'll call it a day too. But yeah, bye, Kiley. Thank you.
Bye. Yeah, of course.
How do I guess I can hang out for a bit. I don't know how to look for chat. How you doing, Trent?
Dandy.
People were talking in the chat, I saw.
Yeah.
But I wasn't paying attention because I can't split my mind like that.
Yeah, no, it's hard to do both.
But yeah, I don't know. Any thoughts before we close out?
Exciting things to come in January.
Exciting things to come in January. So the main things coming in January are so the Skelly Cam is pretty much done. I'm just trying to figure out how to like. It is on pip, but don't install it, or you can't. If you wanted to type pip install Skelly Cam and then you wanted to type Python -m Skelly Cam, you could. But if it doesn't work, don't come crying to me. But the plan is now that is working and stable, and we have much better methods for connecting to the cameras. I can then go back to FreeMoCap and swap out the camera interaction part of it with the Skelly Cam methods, which is easy to do because it was architected well enough that the data should be reasonably relatable. And then then the cameras will no longer be that major bottleneck, and I'll feel comfortable about actually releasing the package as a tool. So we'll release it 0.1 release. And then test it out and then put it on the website as like a standalone downloadable single click application. And then once that's up, then we'll basically just start iterating from there and start, swapping out the planned things to introduce. We're going to replace the Blender output with something that's more sophisticated. Mac Pribble has his new methods for camera calibration that provides like real-time feedback and sort of a lot more information and about what's going on. And so he's been building that, and we'll be integrating that and using it to replace or at least augment the workflow using the current AnyPose-based workflow. Aaron has his visualization tool that he's been working on. That's good for producing like basically like visualizing the data that comes out of FreeMoCap in a way that is like useful for clinicians and whatnot, and like annotating like, oh, this frame to that frame was this condition, and like run these analyses on these frames kind of thing. And so we'll be setting that up as an endpoint for people to be able to like actually look at and manipulate the data. Yeah, and that's the plan. Other stuff too? Probably. Probably gonna do more with the People Labs output, and more laser skeleton stuff. But yeah, we'll see. I think that's that. I think I'm done.
There was a question from Java64, or maybe a question /statement. Can you see it?
Oh, CEB mocap.
Yeah.
Yeah, so that's a guy on Twitter that I mean he's not on Twitter. I saw him on Twitter. It's a cool thing. I don't think it's being supported. I'm not sure. I think he may have moved on from it. It's sort of pulling together similar methods, and it's just one of those things. Um, oh, someone just said on Mastodon, can't comment on Twitch as there is a 1 month sub requirement. You know what that's about?
That's I didn't see that. That's weird.
Yeah, I'll figure that out.
That can't be true because not everybody here is subbing, right?
I don't know.
I don't think so.
Yeah, I don't know. Maybe they just someone posted that, but they had a question. But
it said chat currently is followers only for 1 month. I've changed it, but I don't know if that's gonna
followers only for 1 month.
Basically, you didn't have to sub, but it was follower. So like if you'd been following FreeMoCap for a month, you could talk in chat. But if you have not been following FreeMoCap for a month, you couldn't talk in chat.
Oh, I mean, it just let people. Was there too much going on?
I didn't do it. It was the automated. It was the automated setting.
Because I don't think we're not that kind of channel.
No.
So yeah,
it was also like there's a lot of automated stuff on the Twitch chat that I wasn't anticipating. And so like we'll change stuff for the better in the future.
CEB mocap, it's Carlos, I think is his first name. It's like it's an implementation of like easy mocap and like what's it called? Like some of Michael Black's looking metahumans. I have a suspicion. Yeah. Cannot be used commercially because it's using easy mocap and simple. And it's monocular, so it's just a single camera. And I think he wants to sell. It's not selling it for that much, but it's not open source. And I kind of think I don't think it's being. Yeah, I'm not sure if it's being supported. It might be. I could be wrong. It probably does good job. I've seen he gets good stuff out of it, but it's a lot of like he's using like a lot of the like the best and greatest versions of a lot of these tools, which unfortunately means that a lot of them are not behind friendly licenses. Like easy mocap and simple, it's like free for academic and non-commercial use. So like you can't use it to make a video game. So we're using MediaPipe, which is not the most accurate, but it is very, very easy to set up and very easy to use and has an open license. So you can use it commercially. Yeah. No beef on easy on CEB mocap, but it's kind of, I have a, my general rule is like, if I encounter a similar project, if it's free and open source, I join forces. If it's not, I ignore it. So CG Tinker's Blender mocap was under a GNU license. So I reached out to him and we're working together. I saw CEB, it wasn't a friendly license. So I say, good luck. Yeah. Oh yeah. And yeah, single camera and connect. It's like, okay. All right. I am tired. And I think that was a lot of fun. I think that was a very effective way to get good information out there, and just kind of like we should do more of this in the new year. So, all right, you good, Trent?
Yeah, I'm good.
All right.
Said thanks to chat.
Thanks
for hanging out.
Thanks for hanging out. Sorry if we accidentally blocked you.
I didn't block anybody. It's fine.
Or we blocked them from being able to say anything.
Yeah.
I think we get a lot of people in Twitch where like they're showing up for the first time and there's like they like, hey, what do you like? What's this? Like,
I know. Yeah, we need to make sure that we allow that.
It's fine. One of the other lessons I've learned with all this stuff is like you're gonna mess it up. Like it doesn't matter. Just like every time you do it, you're gonna make mistakes, and just try to remember them for next time. And like getting stuck on the like it has to be perfect thing is just a good way not to do things. And the only way to get good at something is to do it a lot. So do it bad, fast, regular.
Yeah.
But yeah. Okay. Happy holidays. Happy New Year. I unlikely to. I will not be on again before the New Year's. I'm gonna. Maybe, I don't know. We'll see. But yeah, thanks for hanging out. It was fun. Okay. Bye. Look at that. Look at that blur. Exposure all off. Okay. And yeah, and go to the Discord server because that's where a lot of the action is.